Hello students, welcome to this lecture 1 Statistics and Probability. So in this lecture, basically we will discuss NCERT exemplar problem 1 Statistics and Probability. Okay, so let us start. So in first question here we have in the formula x bar is equal to a plus summation a phi di divided by summation a phi. For finding the mean of group data di is a derivation of a of what? In option A we have lower limits of the classes, in option B we have upper limits of the classes, and in option D we have midpoints of the classes, in option D we have frequencies of the class marks. Okay, so finding the mean of the group data di is a deviation from a of what? So basically we know that di, this is actually equal to xi minus a. Okay, that means class mark xi minus assume mean a. Okay, this is actually di that we know in our previous lecture. So that is dis are the deviation of a point of a midpoint of the classes. Okay, so here option number C is correct answer. So now let us move to next problem. So in next problem here we have, while computing mean of group data, we assume that frequencies as what? So in option A we have evenly distributed over all the classes. In option B we have center at the class marks of the classes. In option C we have center at the upper limits of the classes, and in option D we have the center at the lower limits of the classes. Okay, so let us see the answer. So here, in computing the mean of group data, the frequencies are centered at the class marks of the classes. Okay, so here the option number B is correct answer. So this option is correct answer. Now let us see question number 3. So in question number 3 here we have, if xis are the midpoints of the class intervals of group data, if is are the corresponding frequencies and x bar is the mean, then summation a phi xi minus x bar is equal to what? Okay, so let us find summation a phi xi minus x bar. So since we know the mean x bar, this is equal to summation a phi xi divided by n, where n is equal to summation if I. Okay, so summation a phi xi minus x bar, this is equal to summation a phi xi minus x bar. Okay, and this is equal to n times x bar minus n times x bar, that is equal to 0. Okay, so therefore the value of summation a phi xi minus x bar is equal to 0. Okay, so therefore this value is equal to 0, and here the correct answer is option number A. Now let us see question number 4. So in question number 4 here we have in the formula x bar, this is equal to a plus h times summation a phi ey divided by summation if I. For finding the mean of group frequency distribution ey is equal to what? Okay, so we have studied in our previous lecture when we use this formula x bar is equal to a plus h times summation a phi ey divided by summation if I, and here what is that, what is actually ui? Okay, so by above formula is a step deviation formula, so this formula actually formula of step deviation formula. Okay, and this is helpful to find the mean of the given data. Okay, so given x bar, this is equal to a plus h times summation a phi ey divided by summation if I, and here above this formula uy, this is equal to xi minus a divided by h. Okay, so uy is equal to xi minus a divided by h, and here the correct answer is option number C. Okay, so now let us move to next problem. So in next problem here we have the abscissa of the point of intersection of the less than type and of the more than type cumulative frequency curves of a group data gives it. Okay, so then which option is correct. So among these options, in option A we have mean, in option B we have median, in option C we have mod, and in option D we have all of these. Okay, so when the abscissa of the point of intersection of the less than type and of the more than type cumulative frequency curves of a group data gives its actually gives a gives us the median. Okay, so gives us median. So since the intersection point of less than forgive and more than forgive gives the median one the abscissa. Okay, so the correct answer is option number B. So now let us move to next problem. So in next problem here we have for the following distribution. Here we have the two row class and second row frequency. So here we have class 0 to 5, then frequency is 10. For class 5 to 10, frequency is 15. For class 10 to 15, frequency is 12. And for class 15 to 20, frequency is 20. And for class 20 to 25, frequency is 9. Okay, so sum of the lower limits of the median class and model class is what? So let us find. So here the cumulative frequency table is given below. Okay, so here class, interval, frequency, and cumulative frequency. So for this class, frequency is 10 and cumulative frequency is 10. And for this class, frequency is 15 and cumulative frequency is 25. And for this class, frequency is 12 and cumulative frequency is 37. Okay, and for this class, frequency is 20 and cumulative frequency is 57. Okay, and for this class 20 to 25, frequency is 9 and cumulative frequency is 66. Okay, so here if we sum these values, then we'll get this is equal to actually 66. So here the value of n, this is equal to summation a5, this is equal to 66. Okay, now n by 2, this is equal to 66 by 2, that is equal to 33. Okay, and the just greater than the 33, here the cumulative frequency is 37 and the corresponding class in the interval 10 to 15. Okay, so therefore the lower limits of so therefore the median class is 10 to 15. Okay, so 10 to 15 is the median class, and here the lower limit of the median class is equal to 10. Okay, and the highest frequency here is 20. So highest frequency is 20 in this table, and which lies in the interval 15 to 20. So therefore lower limit of the model class is equal to 15. Okay, so the lower limit of the model class is 15 and the lower limit of the median class is 10. Okay, so now we need to find sum of lower limits of the median class and model class. Okay, so therefore sum of lower limits of the median class and model class, this is equal to 10 plus 15 and this is equal to 25. Okay, hence required sum is 25. So here the correct answer is option number B. Okay, so option number B is here correct answer. And now let us move to next problem. So in next problem, here we have this frequency distribution table. Okay, so here we need to find the upper limit of the median class. Okay, so first of all we need to find median, which among this class in table which will be median class. Okay, and then we need to find upper limit of the median class. So let us find. So here first of all we can make table for class, frequency, and cumulative frequency. So here for this interval, the cumulative frequency is 13. For this interval, cumulative frequency is 23. For this interval, cumulative frequency is 38. For this interval, cumulative frequency is 46. And for this class interval, the cumulative frequency is 57. Okay, and if we add them, then you will get this is equal to actually 57. Okay, so given class are not continuous. So this given class are not continuous. So here we first of all so make continuous by subtracting 0.5 from lower limit and adding 0.5 to the upper limit of the class. Okay, each class. So here n is equal to 57, then n by 2, this is equal to 57 by 2, that is equal to 28.5, and just greater than this this class, that class is actually 11.5 to 17.5. Okay, so this is the median class. Okay, and then upper limit of this median class is equal to 17.5. So the correct answer is option number B. Okay, so now let us move to next problem. So in next problem here, for the following distribution, we need to find the model class is what. Okay, so we have given this following this distribution table. Okay, and now this is actually less than type distribution table. So now first of all make the table where marks, number of students, and cumulative frequency will exist. Okay, so below 10 here number of students is 3 and cumulative frequency is 3 also. Okay, and for class of marks 10 to 20, number of students 12 minus 3, that is equal to 9, and cumulative frequency is 12. And for class interval 20 to 30, the number of students is 15 and cumulative frequency is 27. Okay, and for class interval 30 to 40, the number of students is 30, that is 57 minus 27, that is equal to 30, and cumulative frequency is 57. And for this class, number of students 18 and cumulative frequency is 75. And for this class, number of students is 5 and then cumulative frequency is 80. So here we see the highest frequency is 30. Okay, so here the highest frequency is 30. So here the highest frequency is 30. Therefore, the model class is 30 to 40. Okay, so therefore the model class is 30 to 40. So here the correct answer is option number C. And now let us move to next problem. So in next problem here we consider the data. Okay, so we consider this data, and here the difference of the upper limit of the middle class and the lower limit of the middle class is what? So we need to find the difference of upper limit of the median class and lower limit of the model class. So let us find. So let us see the answer. So this is the cumulative frequency table. So here we calculated cumulative frequency. Okay, so for class 65 to 85, frequency is 4 and cumulative frequency is 4. And for this class 85 to 105, frequency is 5 and cumulative frequency is 9. And for the class 105 to 125, frequency is 13 and cumulative frequency is 22. Okay, and for this class the frequency is 20 and then cumulative frequency is 42. And for this class frequency is 14 and cumulative frequency is 56. And for this class frequency is 7 and cumulative frequency is 63. And for this class frequency is 4 and cumulative frequency is 67. So here the value of n, this is equal to 67. So therefore n by 2, this is equal to 67 by 2, that is equal to 33.5, which lies in the interval of 125 to 145. Okay, hence the upper limit of the median class is 145, and here we see that the highest frequency is 20, which lies in 125 to 145. Okay, hence the lower limit of the model class is 125. Now difference of upper limits of the median class and lower limits of the model class. So therefore required difference, this is equal to upper limit of the median class minus lower limit of the median class, that is model class, that is equal to 145 minus 125, and this is equal to 20. Okay, so therefore the correct answer is option number C. Okay, so now let us move to next problem. So in next problem here we have the times in seconds taken by 150 athletes to run a 110 meter hurdle race are tabulated below. Okay, so given this the information in this table. So we here the number of athletes who completed the race is less than 14.6 centimeter is what? Okay, so we need to find the number of athletes. So let us see the answer. So the number of athletes who completed the race is less than 14.6. This is actually equal to 2 plus 4 plus 5 plus 71, that is equal to 82. Okay, so the number of athletes who completed the race in less than 14.6, this is equal to 82. Okay, so here the correct answer is option number C. And now let us move to next problem. So in next problem, here we consider the following distribution. So we consider the following distribution and we need to find the frequency of the class interval 30 to 40. Okay, so let us see the answer. So here this is our table. So 0 to 10, number of students is 5. That is actually get by subtracting 58 from 63. That is 63 minus 58. This is equal to 5. Okay, and marks obtained 10 to 20, number of students 58 minus 55, that is equal to 3. And marks obtained 20 to 30, the number of students 55 to 51, that is equal to 4. Okay, and marks obtained 30 to 40, the number of students 51 minus 48, that is equal to 3. Okay, and marks obtained when 40 to 50, here the number of students 48 minus 42, that is equal to 6. Okay, and marks obtained 50, the number of students 42. So hence the frequency in the class interval 30 to 40, this is equal to 3. So the correct answer is option number A. So now let us move to next problem. So in next problem, if an event cannot occur, then its probability is what? Okay, so we know if an event cannot occur, if an event cannot occur, then that event is called impossible event. Okay, so we know probability of impossible event, this is equal to 0. So the correct answer is option number D. And now let us move to next problem. So in next problem, here we have which of the following cannot be the probability of an event. So in option A, we have given 1 by 3. In option B, we have 0.1. And in option C, we have 3. And in option D, we have 17 by 16. Okay, so let us see the answer. So we know, since probability of an event always lies between 0 to 1. Okay, so probability of an event is always greater than or equal to 0 and less than or equal to 1. Okay, so in option C we have 3. This is actually greater than 1. Okay, this value is greater than 1. So this value, in option D we have given 17 by 16. This is actually greater than 1. Okay, so here the probability of an event cannot be 17 by 16. So the correct answer is option number D. And then next we have an event is very unlikely to happen. Its probability is close to what? So the probability of an event which is very unlikely to happen is close to the 0. Okay, and from the given options here 0.0001, this is close to 0. Okay, so the correct answer is option number A. And now let us move to next problem. So in next problem, here we have the probability expressed as a percentage of a particular occurrence can never be greater than, it cannot be less than 0. Okay, so we know that the probability expressed as a percentage always lie between 0 to 100. Okay, so it cannot be less than 0. So the correct answer is option number B. And now let us see question number 17. So in question number 17, here we have, if probability of A denotes the probability of event, then which option will correct? Okay, so let us see which option will correct. So we know, since probability of an event lies between 0 to 1. Okay, so here the option number C is correct answer. And now let us move to next problem. So in next problem, here we have, if a card is selected from a deck of 52 cards, then the probability of its being a red face card is what? So here the total outcomes is equal to 52 cards. Okay, so in a deck of 52 cards, there are 5 face cards, and that is 6 red and 6 black cards. So probability of getting a red face card is equal to 6 by 52. That is equal to 3 by 26. Okay, so therefore the probability of getting a red face card is equal to 3 by 26. and here the correct answer is option number A. Now let us move to next problem. So in next problem, here we have the probability that a non-leap year is selected at random will contains 53 Sunday is what? Okay, so and non-leap year has 365 days and therefore 52 weeks and 1 day. This is 1 day maybe Sunday or Monday or Tuesday or Wednesday or Thursday or Friday or Saturday, and thus out of 7 possibilities, one favorable event is the event that the one day is Sunday. Okay, therefore required probability is 1 by 7. Okay, so the probability that a non-leap year selected at random will contains 53 Sunday is 1 by 7. Okay, so here the correct answer is option number A. Okay, so now let us move to next problem. So in next problem, here when a die is thrown, the probability of getting an odd number less than 3 is what? So we know when a die is thrown, then total number of outcomes, this is equal to 6. Okay, so total number of outcomes is 6, and what number less than 3 is 1 only here. So number of possible outcome is 1. So therefore required probability is equal to 1 by 6. Okay, so therefore the probability of getting an odd number less than 3 is equal to 1 by 6, and here the correct answer is option number A. And now let us see question number 21. So in question number 21, here we have a card is drawn from a deck of 52 cards. The event E is that card is not an ace of hearts. The number of outcomes favorable to E is what? Okay, so here in a deck of 52 cards, there are 13 cards of heart. Okay, and one is ace of heart. Hence the number of outcomes favorable to E is equal to 51. Okay, so therefore here the correct answer is option number D. And now let us see question number 22. So in question number 22, here we have the probability of getting a bad egg in a lot of 400 is 0.035. Then the number of bad eggs in the lot is what? Okay, so here total number of eggs is equal to 400. So probability of getting a bad egg, this is equal to 0.035, and it implies number of bad eggs divided by total number of eggs. This is equal to 0.035. Okay, and here total number of eggs is equal to 400. So it implies number of bad eggs divided by 400. This is equal to 0.035. Okay, therefore number of bad eggs is equal to 0.035 into 400, that is equal to 14. Okay, so therefore the number of bad eggs in the lot is 14. So here the correct answer is option number B. Now let us see question number 23. So in this question, here we have a girl calculates that the probability of her winning the first prize in a lottery is 0.08. Okay, if 6,000 tickets are sold, then how many ticket has she bought? Okay, so we need to find how many tickets has she bought. So let us solve this problem. So here given total number of solid tickets. Total number of sold tickets is equal to 6,000, and let's see bought X tickets. Okay, then probability of her winning the first prize is equal to X by 6,000. That is equal to 0.08 given to us. Okay, so it implies X is equal to 0.08 times 6,000. That is equal to 480. Okay, so therefore X is equal to 480. Hence she bought 480 tickets. So here the correct answer is option number C. And now let us see question number 24. So one ticket is drawn at random from a bag containing tickets number 1 to 40. The probability that the selected ticket has a number which is multiple of 5. Okay, so we need to find the probability that the selected ticket has a number which is a multiple of 5. So let us see the answer. So here the number of total outcomes, this is equal to 40, and multiples of 5 between 1 to 40, they are 5, 10, 15, 20, 25, 30, 35 and 40. Okay, so therefore total number of possible outcomes, this is equal to 8, and here the total number of total outcomes, this is equal to 40. So therefore the probability that the selected ticket has a number which is multiple of 5 is number of favorable outcomes divided by number of total outcomes, that is equal to 8 by 40, and this is equal to 1 by 5. Okay, so therefore required probability is equal to 1 by 5. So the correct answer is A option. Okay, so now let us see question number 25. So here someone is asked to take a number from 1 to 100, then the probability that it is a prime. Okay, so here total number of outcomes is 100, and so the prime numbers between 1 to 100 are 2, 3, 5, 7, 11, 13, 14, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 56, 61, 67, 71, 73, 79, 83, 89, and 97. Okay, so they are all prime numbers that lies between 1 to 100. Okay, so therefore total number of possible outcomes, this is equal to 25, and here total number of possible outcomes favorable to the even getting prime numbers between 1 to 100 is equal to 25. Okay, and here total number of outcome is equal to 100. So therefore the probability that it is a prime, this is equal to number of favorable outcomes divided by number of total outcomes. Okay, and this is equal to 25 by 100, and this is equal to 1 by 4. Okay, so therefore required probability is equal to 1 by 4. So here the correct answer is option number C. Okay, so now let us see question number 26. So in question number 26, here we have a school has 5 houses, A, B, C, D, and E. Okay, a class has 23 students, 4 from house A, 8 from house B, 5 from house C, and 2 from house D, and rest from house E. So a single student is selected at random to be the class monitor. Okay, the probability that the selected student is not from A, B, C. Okay, so then what is the probability that the selected student is not from A, B, C? Okay, so let us see the answer. Here the total number of students, this is equal to 23. Okay, so total number of students is equal to 23, and number of students in house A, B, and C, this is actually equal to 4 plus 8 plus 5. Okay, and this is equal to 17. Okay, so total number of students is 23, and number of students in house A, B, C, this is equal to 17, and therefore remains students, that is equal to 23 minus 17, that is equal to 6. Okay, so the probability that the selected student is not from A, B, and C, this is equal to 6 by 23. We can also find by using this method also. So here the probability that the selected students from A, B, C, this is equal to 17 by 23. Okay, and then the probability that the selected student is not from A, B, C, this is equal to 1 minus probability that the selected student is from A, B, C. Okay, and this is equal to 1 minus 17 by 23, and this is equal to 6 by 23. Okay, so the probability that the selected student is not from A, B, C is equal to 6 by 23. So the correct answer is option number B. Okay, so these are all about this lecture. So thank you very much to all of you.